What's up? This is Usman Gujar Official, and today I will be teaching you how to apply the product rule and the quotient rule to solve complex equations. So, 5 to the power of 4 times 5 to the power of negative 7 divided by 5. So right here in the numerator, you would apply the product rule. So let's just do that. So 5 to the power of 4 plus negative 7 is 5 to the power of negative 3 over 5. 5 to the power of negative 3 over 5 simplifies to two different fractions. 1 over 5 to the power of 3. It's 1 over 5 to the power of 3 because whenever you have a negative exponent, the simplified form is 1 over the base to the power of the positive exponent. So you get this result, and it's times 1 over 5, which equals 1 over 5 to the power of 4, and this expands to 1 over 625, and this is your final answer. Let's do another problem. So let's say you're given a multiple choice question. Alright, and the question is, which of the following is not a positive number? And you're given a set of multiple choices. 1, 2 to the power of negative 4, 2, negative 2 to the power of 4, 3, negative 2 to the power of 3, and 4, negative 2 to the power of negative 2. Now you're given these 4 multiple choices, and they're asking you which one is not a positive number. So simply you would apply the product rule and or quotient rule to each choice and see which one is not a positive number. So let's do that. 2 to the power of negative 4. As mentioned earlier in the video, whenever you have a negative exponent, it simplifies to 1 over the base to the power of the positive exponent. So in this case, it's 1 over 2 to the power of 4. And this simplifies to 1 over 2 times 2 times 2 times 2. And this simply equals 4. So this is 2 times 2 is 4. And then you add, and then you combine this. 2 times 2 is 4. And this is 16. So find out that 2 to the power of 4 is 16. And this is 1 over 16. And yes, indeed, this is a positive number. So choice 1 is obviously not the answer. Let's take a look at choice 2. Negative 2 to the power of 4. So well, this simplifies to negative 2 times negative 2 times negative 2 times negative 2. So, hold on, let me erase this here. So, we have 4, right? Negative 2 times negative 2 is 4. And then negative 2 times negative 2 is also 4. So 4 times 4 is 16. And yes, indeed, 16 is a positive number. So 2 is also not your choice. It's also not your best choice. So let me just rewrite choice 4 again here. let's take a look at choice 3. Negative 2 to the power of 3. Negative 2 to the power of 3 expands to negative 2 times negative 2 times negative 2. Negative 2 times negative 2 is 4 times negative 2 is negative 8. So there you have it. That is not a positive number. So the correct answer is choice 3. But let's just further on check choice 4 to see and verify our answer. So negative 2 to the power of negative 2, as mentioned earlier, said like as here, it would be 1 over negative 2 to the power of 2, which is 1 over negative 2 times negative 2 is 1 over 4. And so the only negative choice is 3, and it results in a negative number. It is not a positive number. So therefore that is your answer. Let's take a look at another equation or problem. So we have which expression below is not equal to 1/2. Now, another time, let's do multiple choice. So we have a 2 to the power of negative 1. We got B, 2 to the power of negative 1 times 2 to the power of negative 1 as well. And C, 2 to the power of negative 3 times 2 squared. And D, 2 to the power of 4 divided by 2 to the power of 5. Now they're asking you which expression below is not. A common mistake is that people may think that they don't read the question carefully and they think which expression is equal to 1/2. It says not, so we have to find out something that is contradicting the answer 1/2. So same thing like the last problem, we apply the product rule and or quotient rule to every choice and see which expression is not equal to 1/2. So let's take a look at choice A. 2 to the power of negative 1. So as mentioned earlier in the video, when you have a negative exponent, your simplified answer is 1 over the base to the power of a positive exponent. So right here we have negative 1, so it would turn into positive 1. So it's 1 over 2 to the power of 1. And ultimately, 2 to the power of 1 is 2. So it is equal to 1/2. And so as you can see, this is indeed equal to 1/2. So you can cross out and answer choice A. Let's take a look at choice C. Well, let me just erase this here so I have more room. So yes, as we are moving on to choice C, it is 2 to the power of negative 3 times 2 to the power of 2. Now, when you're multiplying powers here, you use the product rule, and ultimately you add the exponents when you have same bases, only when you have same bases. So it results in 2 to the power of negative 3 plus 2 equals 2 to the power of negative 3 plus 2 is negative 1. So once again, like your 2 to the power of negative 1 is 1 over 2 to the power 1 equals 1/2 again. And so this was the answer that C resulted in. And there's again asking you for which expression is not equal to 1/2. So C is ultimately not the answer. So we are left with two choices now, B or D. Let's take a look at B. Actually, let's take a look at D. It says 2 to the power of 4 divided by 2 to the power of 5. 2 to the power of 4 divided by 2 to the power of 5. Now, unlike the previous processes that we've been performing, right here, you apply the quotient rule. And essentially, the quotient rule is when you subtract exponents when you have, say, bases. So this is what we will perform here. So this is ultimately 2 to the power of 4 minus 5 equals 2 to the power of negative 1. Well, guess what? A and C also resulted in 2 to the power of negative 1, and they equaled 1/2. So D must be 1/2 as well. Well, let's just simplify this further. So this equals 1 over 2 to the power of 1, and this also equals 1/2. So with no other choice remaining, we ultimately obviously know that B is our answer. However, you may want to always check that the only answer left ultimately answers the problem correctly. So once again, you apply the product rule in B as well. 2 to the power of negative 1 times 2 to the power of negative 1 equals 2 to the power of, well, you're adding these ones, so 2 to the power of negative 1 plus negative 1 equals 2 to the power of negative 2 equals 1 over 2 to the 2 to the power of negative 2. So that would be 1 and 2 to the power of negative 2. So ultimately, you know that this will be equal to 1 over 4. And ultimately, this is not equal to 1/2. So you know that B is the correct answer. And so let's just take a look at a few more examples. So let's take a look at another example. So we got here 16 to the power of 2 over 2 squared. So what you would do here is simplify this, so it would result in 16 squared over 4 to the power of 1, because 2 squared is the same thing as 4, and 4 to the power of 1 is the same thing as 4, so you can rewrite it as 4 to the power of 1 to make it easier. Now, what you want to do is break down 16 to the power of 2 even more. So it would result in 4 squared over to the power of 2 over 4 to the power of 1. And the reason why I chose 4 to the power of 2 to the power of 2, because it's really the same thing as 16 to the power of 2. It's just a breakdown version of it. And so when you have a question like this, when you have parentheses 4 to the power of 2 parentheses to whatever exponent. Like when you have something like this, what you want to do is apply this rule. So the rule consists of multiplying exponents. So it would essentially be 4 2 times 2, and this will yield 4 to the power of 2 times 2 is essentially 4 to the power of 4 over 4 to the power of 1. And also here, you apply the quotient rule. So when you're dividing two powers that have the same base but different exponents, when you're dividing them, essentially, you subtract the exponents. So let's just take this here, and this will result in 4 to the power of 3. You can keep it as a base or a exponent, but I've choose to make it more in extended form. So essentially this would mean 4 times 4 times 4, which equals, this means 16 times 4, which will equal 64. And this is your final answer for this problem. Now, let's take a look at another expression. Let's just deal with bigger numbers because, in my opinion, we're just dealing with smaller numbers in this video. Let's take a look at bigger numbers slightly. 64 squared over 8 to the power of 3. So now, essentially, what we will do in this equation is the same thing as we did here. You can see here that we broke down 16 squared into 4 to the power of 2 times to the exponent of 2. So we break this up in the same way as well. So, well, 64 divided by 2 is 8. Or as you can see, 16 divided by 2 is 4 as well here. So this would be broken down into 8 to the power of 2 to the exponent 2 over 8 to the power of 3. Let me just erase this because we are already done with this problem, and I want to make more room here so you can correctly perform your operations. So essentially what you do here is, well, what you want to do is break this down even more further. So 8 to the power of 2, as you guys all know, is 8 times 8 over, times 8 times 8 over, 8 to the power of 3 is simply 8 times 8 times 8. Now what you want to do is cross out all the 8s when you're not remaining with anything else. Well, I mean, essentially when you solve the equation. So cross out, this equation you would cross out this, and this. So this and this crosses out, and then the only thing you're left with is 8. And that is your final answer. So let's take a look at our last problem for the day. Since the whole time we've been doing variables, let's take a look at the whole time we've been taking a look at problems that consist of numbers. Let's deal with variables. Well, we're heading into algebra 1 now. So let's take the equation 2 h to the power of 3, j to the power of negative 3, k to the power of 4 to the power of h to the power of 0, j squared, k to the power of 3. So now this, I wanted to use this last problem because in this equation it's basically summing up what we've been doing for the past couple of minutes. So, well, let's start with this. 2 divided by 4. Well, let's just separate this into parentheses, like grouping all of this in separate parentheses, so it's easier for us to perform these operations in between. So this is essentially 2 to the power of 4. Separate this into parentheses. H to the power of 3 over h to the power of 0, and j to the power of negative 3 over j to the power of 2, and k to the power of 4 divided by k to the power of 3. Now what you want to do here is that you want to simplify this even more further. So 2 divided by 4 is the same thing as 1/2, and 1/2 is 0.5. 0.5. Apply the quotient rule here. So h to the power of 3 over h to the power of 0 is h to the power of, just write it for you, h to the power of 3 minus 0. And you guys all know that 3 minus 0 is 3. So this will yield the final answer of h to the power of 3. And j to the power of negative 3 over j to the power of 2 equals j to the power of negative 3 minus 2. And negative 3 minus 2 is negative 3 plus negative 2. And so it is j to the power of negative 5. So j to the power of negative 5. And k to the power of 4 over k to the power of 3 is k to the power of 4 minus 3. And you guys all know k to the power of 4 minus 3 is k to the power of 1. So this is k to the power of 1. And so when you have this type of fraction, what you want to do is that, as you can see here, these are 0.5, h to the power of 3 and k to the power of 1 have positive exponents. But however, j to the power of negative 5 is a negative exponent. So what you want to do is that bring j to the power of negative 5 down into a new numerator and convert this whole thing into a fraction. So what it will yield is 0.5 h to the power of 3, and k to the power of 1 is the same thing as k. So just write k here. And so j to the power of negative 5, well in this scenario, when you have a negative exponent, you're bringing it down and turning it into a positive exponent, and our numerator in this scenario will be 0.5 h to the power of 3 and k all multiplied. So this results in a final answer of j to the power of 5. And we are all done for today. So this wraps up my final video. And I hope you guys learned something out of this. I hope it taught you something. And I usually do these videos for educational purposes. And I hope this video was good to you and educated you. And please make sure to subscribe to Usman Gujar Official. Share this video, like it, please do not dislike it. And make sure to click that notification button to always get notified about my new videos. And this will wrap up this video. Bye.